Aloha, my name is Alina Abramovich, and this is Rogue Wave Science. Before we can talk about rogue waves, let's talk about regular ocean waves and how they form. Normal ocean waves are defined in terms of energy. They are created mostly due to the friction and force of wind that is exerted onto the surface of the ocean. This energy can look chaotic at the source of the wind, in the center of a hurricane or a storm, for example. But as the wave energy moves away from the windy epicenter, it organizes itself into the wave pattern most of us are familiar with. This pattern of wave energy is called a swell and is composed of an amplitude, crests, troughs, the height, the wavelength, and a period, the time it takes for a wavelength to pass a stationary point. Ocean waves are called traveling waves because the energy that they are composed of moves through the medium of water from one location to another. To be clear, it is not the ocean water that is moving to a new location, but rather the wave energy that moves. The water through which a wave passes simply moves up and down in an orbital motion. Now that we know what regular ocean waves are and how they are formed, we can talk about rogue waves. Rogue or freak waves are generally described as being larger than twice the size of the waves that surround them. In addition, rogue waves often arrive from different directions to that of the prevailing waves and wind. So, how exactly do rogue waves form? Turns out that scientists still don't truly understand the physics and mathematics behind the formation of a rogue wave. According to NOAA, the prevailing theory as to how rogue waves form is that of constructive interference. When two or more swells of more or less equivalent size travel across the ocean at different speeds and directions, which happens all the time, they can pass through each other and their wavelengths and heights can mesh and reinforce each other. This creates waves that are much larger than those surrounding them. These waves tend to disappear quickly as the swells pass one another and the regular swell patterns prevail. If two or more swells are traveling in the same direction, these giant waves may stack even higher and can last several minutes before the swells separate. The second most accepted theory of formation of rogue waves is that of focused wave energy. When storm winds form waves in a water current that is acting against the normal wave direction, such as in the Gulf Stream or the Algulhaus current, the wavelengths of the swells may shorten and start moving more erratically and at a faster period. This, in turn, can cause all of the waves in the system to join together and create a monster rogue wave that tends to last longer than the rogue waves caused by constructive interference. To learn more about how rogue waves form and how scientists are learning to predict them, please check out the sources cited at the bottom of this video. This has been Rogue Wave Science. Thanks so much for watching.